In this lecture, we are using mathematical induction to prove the statement. This statement is true for all natural numbers. Actually, this statement is an equation. We want to prove this one is actually an identity. Okay, it is true all the time. What is this? That's the first thing. What's this? This basically says that if n is 5, you can say 4, 6, 11, whatever you want to say. If n is 5, then the left-hand side is 1 square plus 2 square, 3 square, 4 square, 5 square. What is this one equal to? You have a calculator, so you can find out. Okay, so let's find out. 1 squared plus 2 squared, 3 squared, 4 squared, 5 squared. That's left-hand side. If you hit the enter, you have 55. So the left-hand side is 55. Okay. Right-hand side, if they are equal, the right-hand side should also be 55. Is that 55? We go to see. Okay. Divided by 6. And that's basically 5 times 6. 5 plus 1 is 6. 2 times 5 is 10. Plus 1 is 11. Divided by 6. So you get 6 cancel each other. So you have 6 cancel each other. Then you have 5 times 11, which is 55. You see? It says that. Okay? You may say, that's probably coincidence. You may try more if you want. For example, n is 9. Then you have a 1 squared plus 2 squared plus 3, 4 squared, 5 squared, 6 squared, 7 squared, 9 squared, 8 squared, 9 squared. So it's basically you add 6, 7, 8, 9 on that. Previously we have 55, so we just need to add 6 squared until 9 squared. See, look right here. We have 55, so we add 6 squared, 7 squared, 8 squared, 9 squared. Okay, if you hit the enter, you have a 285 on the left. What's on the right? The right hand side is 9. A is 9. 9 plus 1. And then 2 times 9 plus 1 divided by 6. Okay. That's what? That's 9 times 10. 2 times 9 is 18 plus 1, 19 divided by 6. Okay, so you may do is 9 times 10 times 19 divided by 6. It ends up with the same number, 285. Here we have tested 5 and 9. You might say, hey, how about 1? Are we going to get a fractional number on the right hand side? That's not the case. If n is 1, then you know the left hand side is just 1 squared, which is 1. Okay, and then right hand side is 1 plus 1, 2 times 1 plus 1 divided by 6. Is this a fractional? No. 1 times 2 times 2 times 1 is 1 plus 1 is 3 divided by 6. So is 1. Okay. This tells us that the statement is true for n equals 1. Okay. You may say we cannot do this all the time because we have a 159. What is the following number you want to choose? Apparently, we cannot exhaust all the natural numbers. And then here is the step. After we have tested n equals 1, we may say then assume the statement is true for n equals k. What is k? K in this case is 1. Okay, but you may ask, why don't you just use 1 instead of using k? There is a reason for this. Okay, I will explain to you in a minute. We assume the statement is true for k, then we will have a 1 plus 2 squared plus 3 squared plus dot 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 plus k squared should be equal to k plus 1, 2k plus 1 divided by 6. Since we assume this is true for k, in this case, k, there is a flaw is that, we can, at least k can be 1, so this is not going to be ridiculous. Okay? If we didn't test n, then this one might be ridiculous. But we know we already tested n is 1. You can test more, like n is 2, n is 3, until n is 9, if you want it. Then k has more possibilities. Okay, k can be 1, can be 2. If you test it until 9, then k can be 9. But anyway, we assume here k at least can choose 1. Okay, then what we like to do is that we want to prove the above is true for n equals k plus 1. Okay, if the above is true for n equals k plus 1, then we may say in this case, then n equals 2 might be true, then will be true. Okay? Yeah. Because we started with n equals 1, and then if we can prove the above is true for k plus 1, then you know the above should be true for n equals 2. Okay? So our goal is what? Is want k equals n equals k plus 1. We want the above also be true. So what we need is we want 1 squared, 2 squared, 3 squared, plus k squared, plus k plus 1 squared. We want the left-hand side like this, then the right-hand side we want is k plus 1. That's our n. You replace n with k plus 1. Then in the second bracket, you want k plus 1 plus 1. And then the third bracket, you want 2 times k plus 1 plus 1, the whole thing divided by 6. This is what we wanted. Okay. Now,